This is the extraction of caffeine from tea laboratory experiment. On our left, we have 200 milliliters of boiling water on a stirring hot plate, along with our 5 pre-masked tea bags and some of the student locker glassware that will be needed for this experiment. In the middle, we have some of the chemicals and equipment that will be available on your laboratory cart. And on the right, we have our vacuum filtration apparatus, along with our organic waste containers in the back. Now, let's begin with step 1. Our water finally started boiling a few minutes ago, so now we're going to transfer 60 milliliters of that water into the smaller 150 ml beaker that actually has the 5 tea bags already in it. For safety, you want to use a pair of beaker tongs or hot hands to move these items. The protocol mentions using a watch glass placed over the top. I would recommend this same technique, or if the tea bags are floating up, use a smaller beaker. This will keep the extra weight and ensure the tea bags stay in the hot water while you're allowing it to seep. We are now going to perform a vacuum filtration of our tea solution. I want to point out that it's important. You're going to be collecting the solution that passes through the beaker funnel into the vacuum flask. So you want to make sure you have a clean vacuum flask to start. I also want to point out that by using a second beaker, you can squeeze the tea bags to get some more of that solution to come out. Now, add 5 ml of hot water to this beaker twice and repeat this process. We will now remove the vacuum filtration flask and place it on our stirring hot plate. After adding 1 gram of calcium hydroxide and 20 grams of sodium chloride, we stirred the solution and now we place it on a stirring hot plate. We will now wait for the solution to boil for 15 minutes. Here our solution is just beginning to boil. You have to look closely to be able to see it. This is a separatory funnel. This portion is called a stopcock. It's currently in an open position. To close it, turn it 90 degrees. We're using a glass funnel and piece of filter paper to assist us in decanting our solution after it's cooled off. Once we have completed decanting the tea solution, we are now ready to move on to step number 9, adding 20 milliliters of ethyl acetate. At this point, you can already see a 2-layered system has started to form. The aqueous tea solution is on the bottom, and on the top is the organic ethyl acetate solution. To relieve pressure, we're going to turn the separatory funnel upside down and open the stopcock to allow gas to escape. Close it, and now let it settle. We will now pour off our bottom aqueous layer into the beaker. The remaining organic layer will collect into an Erlenmeyer flask. Pour the aqueous layer back into the separatory funnel. Then we will pour another 20 milliliters of the ethyl acetate again into the separatory funnel. Repeat this process one more time of separating the layers between the aqueous and the organic. We will now combine our organic layer with the crude caffeine and 20 milliliters of 10% sodium hydroxide in our separatory funnel. again, we can see we have a two-layered system. First, we're going to pour out the aqueous layer. Now we're going to pour our organic layer into the Erlenmeyer flask. Then we're going to add our anhydrous sodium sulfate. This 100 ml beaker has already been pre-masked. And now we will slowly decant our ethyl acetate solution containing our desired caffeine product while not catching the excess sodium sulfate that is on the bottom of the flask. Once the excess ethyl acetate has evaporated, we will only be left with our remaining caffeine product. The pictures at the end of this video will show you the product, its mass, and final melt temp analysis.